Okay, how do we find the hypotenuse on this number 1? Pythagorean theorem. We have two sides of a right triangle. We can find the third using Pythagorean theorem. Now I know, or I may not know, but some of my students have been trying to get rid of the radicals first. There's no reason. You should not be afraid of radicals or square roots. They're just another form of a number. All we have to do is take these and plug them into our Pythagorean theorem. A squared plus b squared equals c squared. So we're going to put the square root of 26 squared plus 3 times the square root of 6 squared is equal to c squared. Now, what happens when you square a square root?
It cancels.
Why do they cancel?
Because it's like reversing.
Yeah, because the opposite operation of squaring is square rooting. So, just like if you were to take 4x divided by 4, that's 4 times x, and also x divided by 4. Those are opposite operations. That's why those 4's cancel. So, here, the square and the square root cancel, and I'm left with 26. This makes sense too, because when I think about what's actually happening here, I'm multiplying the square root of 26 times the square root of 26 when I'm squaring. Do you guys know how to multiply radicals? Yeah. What do you do? What do you think you would do here? No. So all you have to do when you're multiplying radicals is you multiply the number inside. So it remains under a radical, but now it's 26 times 26, which is? 6 what? 76. Good. What is the square root of 676? Oh my gosh, it's 26. Look, anytime you multiply a radical times itself, it's just the number inside. So this is showing you visually, okay, why does the square and the square root cancel each other out? Because when you multiply a radical times itself, you're left with just the number inside. So that takes care of that first part. What do you think happens here with 3 square root 6 squared? Yeah, beautiful. So here, we're going to multiply the whole numbers, and we're going to multiply the radicals, right? So 3 times 3 is, and the square root of 6 times the square root of 6 is just 6, right? Remember, when you multiply a radical times itself, you're left with just the number inside. So this is just 9 square root 6, which is, 9 times 6, which is 54. So I replace 3 times the square root of 6 squared with 54. So now 26 plus 54 is 80. Y'all got quiet super quick. Did I lose people? Okay. So now what do we do? Yeah, you square root both sides. So what do you think we're going to have to do here? You have to simplify this radical. Remember, from now on, anytime you're tempted to hit that square root button on your calculator, stop. Because that probably means I'm instead wanting you to simplify the radical. So, what does 80 factor into? 20 and 4, sure. And then 20? 10 and 2, sure. And 10? And then 4, 2 and 2. So, what pairs do I have? Now, we're still a little bit fuzzy on what happens from here. What goes on the inside? Your 5, right? Oh gosh. Your leftover, right? Your leftover number goes on the inside. What goes on the outside?
4.
Now, why is it 4? You have a pair of 2s, so you write down 1, 2. You have another pair of 2s, so you write down another 2. And because there are 2 things on the outside, you multiply them together. What is 2 times 2? So our answer is 4 square root 5. Does that make sense? Okay. So now, number 2, solve for D. Is it easy, just boom, right off the bat, solve for D? Why not? So yeah, you have to know what method. So what method could I use here to solve for D? Now, first of all, what is the T method a method of? What are you doing? Geometric mean, right? Why can I use geometric mean here? You have an altitude drawn inside of a what type of triangle? Anytime you have a right triangle with an altitude, yes, you can apply the geometric mean. Now, we cannot solve for D right off the bat because we recognize we have to use geometric mean here. So I would find a big V and I would find a little v, but look, there is another variable on my v. So what do you think I'm going to need to solve for first? I'm going to need to solve for the b using the T method, right? Because I have this altitude, it's 8, and I also have b on this base. So it's an upside down T. I can easily solve for b using the T method. Now, which of these numbers matters where it goes in your proportion? Why does the 8 matter? The 8 is your altitude, it's your geometric mean. So it's written twice, diagonal from itself. What are the other 2 values on the T? B and 4. Boom, we have our proportion. So how do I solve this? And what tells me I can cross multiply? The equal sign, right? Only when I have an equal sign can I cross multiply. So I have 4b is equal to 64. Divide by 4, and what is b? 16. Whew, okay, so I'm one step closer to getting D solved for. There are actually now 2 ways I can solve for D. Somebody say one of them. I can use the Pythagorean theorem. What else can I use? The V method. Now, because I hope we're all more familiar with Pythagorean theorem, I'm going to show you V method just so you can see it again. Okay? So, yes?
What numbers would you choose to... Oh, wait, no.
Okay, yes. Now, what am I looking for with the V method? 2 V's, right? A little one and a big one. So I know I'm going to need to solve for D, so that's one of the sides of my V. And then I wouldn't go this way because I have another variable over there. Instead, I would go this way and I have a little v all the way up to 16. And then I have a big V along D again. But then all the way up past 16 to 4 is my big V. So, what side do those 2 V's share? The D. So the D is written where? Twice diagonal from itself. Good. And then what is the other length of the little v? 16. And what is the full length of the big V? How did you get 20? Yes, the full length is 16 and 4, which is 20, is the full length. So that's what goes here. And then we have D times D, which is equals 16 times 20, which is good. And then we square root. So what does that mean we're going to have to do? Simplify. So I'm going to do 32 and 10. And then 8 and 4. And 4 and 2. I'm just going through this really quick because the bell's going to ring. I'm so sorry. And then 4 splits into 2 and 2. And 10 splits into 5 and 2. So my pairs are a set of 2's, a set of 2's, and a set of 2's. So how many 2's go on the outside of my radical? And what goes on the inside? That leftover 5. So what's 2 times 2 times 2? 8. Woo! So my total answer is 8 square root 5. Woo. Any questions on these problems? All right.